We're now going to use what we've learned about the trig functions to help us solve some problems. So we're going to start off with some problems that involve angles of elevation and angles of depression. So this says, at a certain time of day, the angle of elevation to the sun is 40 degrees. To the nearest foot, find the height of a statue whose shadow is 18 feet long. Okay, so let's draw the situation. So we've got the sun, and we've got a statue. Okay, and the sun is shining down on the statue and making a shadow. Okay, so we're told that that shadow is 18 feet long. Now, what the angle of elevation is kind of how the angle that you have to look up to see the sun. So we're saying that this angle right here is 40 degrees. Now, we have to make kind of one assumption when solving the problem, and that is that the statue is standing up straight. Okay, because if we assume that, we get a right triangle. So we now have a right triangle that looks like this, where this side is the statue, this is the shadow, and we're told that this is 40 degrees. Okay, and we want to find that value x. Now, we want to look at our 40 degrees here and think of that as our angle. The x then is our opposite side, and the 18 is the adjacent side. So we kind of need to think back to SOHCAHTOA and say, okay, which one uses the opposite and the adjacent? Well, that's the TOA, the tangent. Okay, so we can write out the statement that tangent of our angle, tangent of 40 degrees, equals opposite x over adjacent 18. And to solve for x, we need to multiply both sides by 18. So we can say right now that x equals 18 tangent of 40 degrees. Okay, so if we pull out our calculator, first make sure you are in degree mode. So mode, make sure you're in degrees. Okay, then we can put in our calculator 18 tangent of 40 degrees. And since our shadow is in feet, this would be in feet. So we're saying if we round to, let's round to 2 decimal places. This is 15.10 feet tall. Okay. So the next one says the Washington Monument is 555 feet high. If you are standing 1/4 of a mile from the base of the monument and looking to the top, find the angle of elevation to the nearest degree. Okay, so if this is our ground, we've got the Washington Monument, which we're told is 555 feet. And then we're told you're standing 1/4 of a mile away and looking up. Now, we actually kind of make a dumb assumption, but for here, we're going to, especially since you're so far away, we're really going to take the angle of elevation from your feet. So we know that this is 1/4 mile. And we need to make sure we've got the height of our Washington Monument in feet, but we've got the length you are from it in miles. So we need to do a conversion. Now, there are 5,280 feet per 1 mile. So if we want to convert our 1/4 miles to feet, we would take 1/4 of a mile times 5,280 feet. So 1/4 times 5,280. So 1/4 mile is 1,320 feet. Okay, now this is the angle we're looking for. And again, we have the opposite side and the adjacent side if we're looking in that angle. So we're going to use tangent, and we're going to say tangent of theta equals 555 over 1320. Now, here's something that we'll learn about a little bit later, but we'll give you kind of the basics of it. We need to get kind of our theta out of our tangent. What this means is this is our x, we have our y, we need to kind of go backwards. Now, when we've learned about functions, we learned about inverse functions that would undo a function, and that's what we need here. And so the inverse function is called tangent inverse, and it's kind of it has a -1 as its superscript. So we're going to take tangent inverse of both sides, so a tangent and a tangent inverse kind of cancel each other out. Here we just get theta. Remember, if you compose a function with its inverse, you just get the identity. And then we're going to do tangent inverse 555 over 1320. Okay, and if we round to 2 decimal places, we would have 22.80 degrees.